Good morning, everyone. So homework 4 is due, as I record this, in about a week. And in that assignment, you're supposed to be doing planning to come up with a tour between the various moons of some planet. For the easy case, that planet is Kerbin. We talked a little bit about how that might be a graph search problem. We talked a little bit about how that might be a sort of general search problem, and how either of those can be relatively complicated, and so you probably want to come up with some heuristic optimization to try to get that to go quicker. Although, for the case of 5 moons in the Joule system, that's not necessarily a problem, but yeah, that's the upcoming assignment. And for the assignment after that, we'll be working with some of the same ideas, but instead of doing it in Kerbal Space Program, we are largely done with Kerbal Space Program assignments for the semester, although you'll be able to use Kerbal Space Program as the basis for your project. Homework 5, which is due 2 weeks from when I'm recording this, we'll be back to working in Gazebo. So this assignment, you will get a Gazebo set up, a lot like in Homework 1, and let me go ahead and pull that down here. So you get the starter code. Apparently, you get the starter code, and if we unpack it, we end up with the same sort of layout that we had in Homework 1. We have a worlds directory with a couple of Gazebo worlds in it. We have a models and plugin directory that define a simulated robot. Simulated robot's different from Homework 1. And then we have a brain directory that has starter code in it. Let's go ahead and actually start up the thing. So the instructions here are you're supposed to type make in order to build this. So I'm going to do that. And then it says that we have 2 different simulations that are provided in the starter code. We have the demo simulation, and then we have a Homework 5 sim simulation. And these are 2 different mazes in Gazebo that you're expected to write a robot control program to solve the maze given the provided simulated robot. So once this thing finishes building, we can go ahead and head over here, and oh, we can't see what's going on at all. Let me make 2 windows so we can see what's going on. We're going to go ahead and start this demo simulation. And Gazebo starts up, and let's take a look at Gazebo here, and we can't really see what's going on, so I'm actually going to live shrink my video here. And here is our demo simulation. So again, we have a robot. This robot appears to have a laser scanner, just like the Homework 1 robot, but instead of having a 360-degree laser scanner, it's only looking at the forward arc, and actually the interface that you get, you don't get a laser scan interface, you just get a distance to closest obstacle interface. So you can see whether there's an obstacle in front of you and how far away it is. What you're supposed to do is drive this robot through this maze over to this target. The target's actually in exactly the same position as in the Homework 1 starter code, but in addition to getting a sort of simulated sonar sensor, that's what I'm going for here, instead of a laser sensor, you have a angle sensor that tells you what your absolute angle is in the world, as if you had a compass on board or a magnetometer that you're using as a compass. It's a common sensor in a real robot. You no longer have a perfect pose sensor. So you know that you need to drive basically straight forward, right? We can see that the starting position of the robot and the goal position of the robot is basically a straight line, but you don't get for free how far you've gotten. And so the puzzle is, how do we get this robot to drive through this maze, because that's what this is. It's not the most difficult maze. We can see how to do it as humans pretty quick. But how do we get the robot to drive through this maze without running into walls and get to the goal? And realistically, because we don't have any pose information, that's going to involve exploring the maze. But because we do have direction information and we have that knowledge that we're going straight forward, we might be able to do an exploration of the maze that's a little bit more efficient, where we prefer going forward rather than going sideways. Now, the sort of initial solution to maze solving that you're likely to come up with is to use a wall follow strategy. Traditionally, you go left and follow and take every left turn. So if we do that, we'll go this way, then we'll go up this way, and 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 then we'll come back and we'll go this way, and this way, and this way, and this way, go all through here, and we'll end up back where we started eventually without ever hitting the goal, because in this particular layout, the goal just doesn't happen to be on a left wall. It also doesn't happen to be on a right wall. It's here in the middle of the floor in this random spot. So both the pathing that you do and your exploration procedure are going to have to be a little bit more complicated. And it may be the case that you're going to have to produce some sort of map so that you have some idea of where you've been. Now that's difficult when you don't have any way to estimate where you are, and that's sort of the puzzle of this assignment, is to come up with a relatively simple strategy that allows you to do an efficient exploration of this maze with the information that you have. And we can't use some of the more advanced techniques that you'd want to use for general maze solving in robots, because we don't have that reliable position, and we don't have much sensor information. We can just tell whether there's an obstacle in front of us or not. The two big things that we have going for us, though, are that everything is a right angle here. It's all perfect right angles in the maze. And so we can tell clearly the difference between sort of open space or a doorway through the horizontal walls and no doorway through the horizontal walls. And that is the layout here, that we have this sort of grid. And we have perfect information about what angle globally our robot is pointing. And so with those two pieces of information, it may be possible to, as we drive around, build sort of a grid graph of the world and sort of keep track of where we are. It may not be a perfect grid graph of the world, because we may not know perfectly how far we've traveled, because the motion actuators on this robot are sort of awful. But we know which direction we're facing. And we know that there are a limited number of doors through each strip, like between a strip and the next strip. And so we should be able to keep track of when we're traveling through a door and which strip we're on. And with that information, it should be possible to do sort of a like relatively effective abstract map of what's going on here. So that's the idea of the assignment. The first task that you'll be doing is trying to solve this maze, but we have the ability to generate random other mazes. So if let me just copy our demo world, and then if we go over into this maze gen directory and type rake, it's going to generate a new demo 1 world here. So now if we run our demo.sh again to start that sim, oh, it crashes. Let me try harder. I don't know why Gazebo likes to crash here. Eventually, I think it's something to do with the OBS recording, that it really doesn't want to deal with it. Oh, and the tank control plugin wasn't working. But this is a different maze. This is supposed to be a different maze. This is not even a different maze. It generated exactly the same maze. I don't know. Oh, this is just the wrong homework 5. We're supposed to be temp homework 5 starter demo. Alright, so here's our fancy new maze. We generated a different one. It's not drastically different, but the connectedness is slightly different. And so this will give you the opportunity to test your robot on multiple mazes to make sure that you've actually produced a robot that solves this class of mazes rather than just a robot that happens to do well in one maze. And in this case, we did get another maze that is solvable. It's possible for this maze generation script to generate unsolvable mazes. If you generate an unsolvable maze, just generate a new maze. It's fine. But yeah, get so that you can solve a couple of these. And then finally, what I want you to do a video of is one particular maze that I generated that isn't like drastically exciting compared to the other ones. But here's the final maze. Is this one. And you'll be doing a video of solving this maze. And in the video, you'll want to state who you are and what strategy you ended up using to solve the maze. So that is homework 5. Good luck finishing up the Moon Tour assignment, and then good luck getting started on this assignment.